in my industry, I'm normally dealing with hospitals, data centers, and critical environments that rely on large amounts of stored diesel fuel on site so that they can run anywhere from 3 to 7 days. I have one client that actually has enough fuel that he can run a whole month. But what they don't realize is that once the fuel leaves the refinery, 26 days after that, the fuel is starting to degrade. And because it's an organic substance, it likes to go back to where it came from. So it loves water. And I'm kind of varying off this because of the level of knowledge in this room about all these things. So here's an interesting comment about your OEMs, because I know there's been a lot of conversation about OEMs and their maintenance processes. This was an article in Caterpillar's Run Ready magazine from 2010. And they've published this. It was a very short article, not very prominent, but even they realized that they needed a polished approach to diesel fuel if it's being stored for any length of time. So in facilities like data centers, hospitals, it's critical that they have a good supply of fuel, because 80% of all diesel failures on startup are caused by two things: bad fuel and batteries. That's the only thing that'll take them down. So this is a typical process. The fuel wants to repolymerize, so it wants to get back to where it came from. And there's a big issue with oxidization. So what we get is this process called diesel sludge, and it's a really gooey, stringy type substance. You can't filter it out, but we can prevent it. So if you get that type of thing in your system, excuse me, it'll plug the filter, stop the generator. Now, there's been a analogy or a thought process that there's diesel or algae in the diesel fuel. You can't grow algae unless you have sunlight. What's actually happening in the fuel is you're growing yeast, because yeast loves a dark, enclosed environment. So temperature is very critical when you're dealing with diesel fuel. In stored fuel, you want to have it at the optimum temperature, because if you start raising and lowering fuels, it has a tendency to draw water into the fuel. And with the advent of the biodiesel fuels that we're currently using in a lot of these sites, the biofuel has a tenacity to hold a lot more water than what regular diesel fuel will. So this is an interesting concept, because there's two types of filtering. There's a coalescing filtering, which is very common in the industry, and we use a covalent bonding type filtration process. With the ULSD blends that we have, there's still a possibility of pushing over 40 to 100% of water that may be coming into that filter. So your protection really isn't there. It can be shocked. That filter can be shocked, and the water will pass right through it. The problem is, because they're working at such low pressures, because of the coalescing filters, if you can't put a high pressure on them, because they need time to separate out the water. And with our technology, it's different. And I'll get to this in a second, but I'll just explain our technology for you. So a covalent bonding filtration system is, we use a microfiber glass filter material, which is good for 0.45 microns. On the inside of that filter, we coat it with a resin. So the resin came from the oceanic cabling industry. So when you lay a cable in the ocean and it has multi-layers, in the top 2 layers is sandwiched this resin between the outer casings. So if an anchor or if something goes across that cable and it gets cut, the resin immediately turns to a gel and self-heals that cable. So how we deal with it is, it will pull the water molecules right out of dissolved water in the fuel, and it'll immediately change to the gel, and then we just filter the gel out of the fuel. But the difference is, covalent bonding is a true water blocking technology. So once you've spent all the resin in that filter and it's plugged the filter, the unit's down and dead. So we can't use it in a fuel train to any piece of equipment because of that reasoning. So in our industry, we have all the manufacturers pretty much with the same fuel specification. The only one different is MTU, and I'm not sure why they are different on those 2 items, but so they're all basically in the same category. And I don't think that's any different than what you know currently anyways. The only difference would be that the fuel injector manufacturers, because of Tier 4 engines, and definitely moving to Tier 5 with that, they want it cleaner. They want it down into around 12, 13 on that first number, and getting down in, I think it's 12, 7, and 5 or 6. So that's extremely clean. But we can see here, human hair, and this basically is a normal particle which is within the 10 to 15 micron range. It's very common to get in fuel. And a film on a bearing in a fuel system, so in your injectors, you're down to 1, 2 microns. So if you pass through a lot of contaminated fuel, and if it's a hard silicon-based or material, you're just scoring the heck out of that injector. And you're also opening up the outlet of that injector. So now your efficiency's gone, your combustion flame is virtually altered and not giving you the performance of that engine. Excuse me. So this is just your typical ISO chart. Anybody understand how the chart works? Basically, it's a rating system. So you have a rating between 1 and 28. Every time you change a level going up in number value, you double it each number. Every time you go down, you half it each number. And what it gives you is total count in that range. So we get the actual numbers from our laboratory that we use, and they do an actual count of particulate. So in my time dealing with this and taking multiple samples, I found that there's an industry perception on what bad fuel should look like. In the industry that I work with, we deal with what's called the CSA 282. So the CSA 282 is a guideline for anyone with an emergency generator to deal with their testing, their maintenance, and their fuel. So every year they have to get the manufacturer out and do a maintenance on the engine. They have to do a load test. They have to test the fuel. If the fuel fails, there's 3 ways that they can deal with it. They can run it until the tank's empty, which doesn't clean the tank. They can remove the fuel and dispose of it, which doesn't clean the tank, or they can filter in place, which is truly the only method that you get the tank clean. So this is a typical sample that we normally would see that everybody agrees that's a bad sample. So what we have is we have fuel on top, and it's cloudy because it has entrained water in it. We have the middle layer between the surface of the water and the fuel, which is now starting to emulsify and grow bacteria. And in this sample, I'll explain why it's so clear, but that's considered to be standing water. Now this is a 90,000 liter tank for a correctional facility in Toronto. It was under construction. Somebody left the lid off. It snowed. They didn't care. And then all of a sudden we got water in our fuel. So in a 90,000 liter tank, they had almost 7,500 liters of water in the bottom. But that's what you would consider a bad sample. So here's the test result. We didn't get a cleanliness test because it was too contaminated, but we have 0.11% of water, or 1,100 parts per million. Okay? Not a good situation. So, a not so typical bad fuel example. Now, within the 282, they refer to the ASTM clear and bright testing, which is a clear vessel, clean, clear vessel, and what you do is you take the sample, you shake it up. If there's any particulate in it, it should fail. And you can normally see the water, if there's any water in it, that settles out after a few minutes. Now this sample, we shook it, we let it stand, and we didn't see any, we could read through the fuel, and we didn't see any standing water at the bottom of the test vessel. So here's the results for that fuel. So it didn't meet the ISO code, but almost 1,000 parts per million in dissolved water. You would never know from that sample that you had that kind of a water problem in that fuel. So that's dissolved water in that fuel holding on to the biodiesel and the diesel fuel. So that sample obviously doesn't meet the Canadian standards. So this is another example of our process. So this particular case, we had approximately a 65,000 liter tank. We had approximately 750 to 800 liters of water in that tank. We struggled for quite a while trying to figure out how we got that water. We tested piping, we pressurized the tank to see if there was any leaks. We had nothing. It was determined after some pretty heavy investigating by the client that his fuel supplier gave him some extra water with his fuel. So the process to deal with this is we come in with a vac truck and we'll vac off the bottom of the tank until we reach a consistency that looks like this. So like a pinky milkshakey, strawberry milkshake color. Then we will put on our filtration system and we'll filter it to this position. So when we actually started here, we ran for approximately, I'd say, 1.5 minutes. And the system shut down. So we pulled out about 25 liters of water from that fuel sample, from that fuel condition. We changed the filters, and went back at it, and we went for about 8 hours or 5 complete turns of that tank, not having to stop and change again. So we were just filtering out the particulates after we got rid of the water. So that's how good that covalent bonding system is to attract that water out of the fuel. So we got down to below ISO standard, and this is the real key number here, is we got down to a Carl Fisher reading of 65 parts per million. Now it's difficult to get below 65 in, like Ontario, we're pretty high humidity. So we're churning that fuel at a pretty high rate. We're churning it at 100 gallons per minute. So the fuel is moving all the time, and it has that tendency, because the tanks are vented, to draw in moisture. So we have seen 45, but that's hard to get below. In Phoenix, they can get down to 2 or 3. So that was just the ISO cleanliness on this particular system here. We have this system installed. We have 2 types of systems. We have a cabinet system with a pump on the bottom, and this system is we actually put a submersible pump in the tank. So that's a 65,000 liter tank, and we use a submersible pump to pump the fuel through the filtration system. So this is a typical system. So a stainless steel container, because microbes can't grow on stainless steel, that's why we do that. Our filter is housed inside. We have controls to schedule operation, and it's a pretty basic type. So I mean, it's like OneEye's magnetic filtration. You know, other than the technology, it's a simple process. So we come in 3 different varieties. I just wanted to make mention with something that Dale said that falls back into this CSA 282 maintenance proposition. And I have the same argument that you have, and that is CSA require the owner-operator to change the oil in their standby generators every year on that maintenance scheme. So here's what you're dealing with. A good operator will run his machine to test as per code once per month, anywhere from a half an hour to an hour. Outages in Ontario, and probably here, you're probably not looking at anything more than maybe 5 outages, averaging 2 hours an outage. So add up the number of hours you've got on that oil, and really you're just pouring good oil down the drain and encouraging the OEMs to spend more money. Now the other thing that we oh, did I hurt somebody?
Yes.
Oh, I'm sorry. I'm sorry. Yeah, no, he's an OEM, he doesn't have feelings. The other issue that we're running into is that test process, right? So 282 right now, they'll accept a clear and bright test. But as you could see, the clear and bright is nowhere near what a chemical test will provide for you. So we were starting to influence the CSA committee on that 282 to move forward and change the testing to a chemical type test, so that you send it to a lab, you get an ISO rating, you get a Carl Fisher rating, you can do a few other tests to distillation and cetane rating if that. But really, when you get to this point, you've got the fuel stored in the tank. There's really nothing more that you can do to that to enhance it, even with some of the additives that are out there today. You're not going to make it a lot better than what it already is. You know probably what the OneEye magnet filter looks like. So this looks a lot different than a coalescing filter that you would get from a lot of the other vendors. We have made this filter out of a coiled stainless steel material, both inside and outside. We have a glass fiber filtration media in the middle, and lots of it, because that's the only way you really filter. It's all got to do with the amount of material that you're passing the fuel through and the time that you pass the fuel through that material. So what, as I was saying with the resin is actually on the inside of the filter media. So we filter down through the middle of the filter and push it out. So we have tested this filter and applied 50 pounds per square inch on a blocked filter to see what would happen. We do get a bit of the resin, but it only will coat the holes. It won't fall off the system or off the face of that filter. So our system's shut down at 25 psi, so we're pretty much guaranteed that we're not going to have any infiltration of the resin into the fuel side of the filter. And if it does fall off, it's heavy enough, it'll just drop to the bottom of the canister. So we have a patented process, or filter media. So it's not the filter media itself, but it's the combination of the resin on that particular media in that canister arrangement. Okay, so that's what the patent's on. So as you can see, as I just explained with the other one, how that process works. And here's kind of a depiction of the process as it moves through the filter media. So this is one side of that filter canister, and that's the fuel passing through it. So as you can see, the particulate and the water are discharged through that filtering process. And the big thing that some of our clients like is it's self-monitoring, so they don't have to spend a lot of time with it. They don't have to deal with having to keep close eye on it. If it's getting to a point where the filters are filling fast, then it just shuts itself down. We have had the filter tested, and we are at a 99.65%. So what that means is basically the weight of the particulate passing through the filter is weighed before and after to figure out how much we have captured. So very efficient filter for particulate. And we can deal with a lot. Obviously, diesel, biodiesel. We can filter 100% biodiesel fuel. Difficult at best, but we can do it. Gasoline with an E85. We have done some in the Maritimes in Nova Scotia, trying to help them with their E85 problems. We can remove water from glycol, although we really haven't had too many projects because it's usually a 50-50 mix, and it does take a lot of filters to get an end product. Not really economical. We do hydraulic fluids, because basically it's the same problem that you have with fuels, is particulate and water. And we have done a few projects with lubricating oils. So this is just a depiction of a permanently installed unit, and what the process is pretty simple. I'm just going to fast forward through. So this is our particular unit. So it's stainless steel construction, it's socket welded. We can use it for indoor, outdoor. We can, comes in whatever ratings are required. And we can apply it from 500 liters to 5 million liters. So that's a large unit that we've got installed in a data center in Florida. So I'll just say this just because of the things that have happened in Florida over the last little while we all know about. So Verizon have a extremely large data center in Florida. So they have a 200,000 square foot data center. Normally data centers are anywhere from 20 to 40,000 square feet. So it's huge. They have 12 55,000 gallon fuel storage tanks. So about 2.5 million liters of fuel on site. They didn't have any issues with the hurricane going through, and that site is in Tampa. So they had a lot of rain, a lot of issues with water. So because the fuel was dry already to begin with, it did take on some moisture, but they were able to maintain their site because it was running for a few days after the hurricane. Basically, what we are telling our clients is that you have to realize that there's an issue with fuel. You can't turn your head away from it any longer. You've got to face it. You've got to do something, because if you don't, eventually you'll get hit with an issue. And an example of that is back in 2001, we had the ice storm in Quebec that took down pretty much the whole power system. One of your local telephone companies had a number of locations in Quebec that were running on diesel power. They called for a refill of about 9 sites. They went out and they started refilling them all. And what started to happen was about 2 hours after they filled them, the units went down. And the reason they went down was because nobody was concerned about the contamination in the bottom of the tank until the guy with the pump truck came, started pushing fuel in it at 400 GPM and stirred it all up, and that was it. So a lot of my clients, anyways, for sure, they continuously tell me, I don't have a problem. Every time I turn the key, it runs. Right? So the only true sale for me is when it fails, they'll call me. I don't want to step on Roger's toes there, because we're both basically in the same industry. So we've got some pretty high profile clients, and we're making some headway. The biggest problem with this particular industry is educating the client. You have to, and they're not willing to accept it because money, and because they've never had an issue. So why spend money on something I've never had a problem with?
Yeah, how do you regenerate the filters?
We can't regenerate the filters. The filters, it's a one-time product. And that's basically because of the gel material, because it plugs it right up.
How many gallons of water can you get out of one filter? Is there kind of an estimate or anything?
Oh yeah, we know exactly. So that filter that we saw, so this is a 12-inch filter, 8-inch circumference. We can put 5 liters of water in that and 20 pounds of sediment. We have an 18-inch filter, so we're looking at about 7.5 liters. I'm not sure why we don't get the same performance out of it, but.
Okay. So on a normal 20,000 gallon tank sort of thing that you've got for reserve and everything else, how often would you have to run that through, on an outside? Like, I came from electrical generation as well. Okay. And so standby generators are a norm, and yeah, the fuel is always old and all that stuff. So how often would you have to run that to keep it pristine?
To keep it at its optimum, we recommend doing it once a week.
Okay.
And usually minimum 3 turns.
Okay.
Okay. The filter longevity is fairly good on this if you start with clean fuel at the beginning. I've had clients go almost 22 months. Yes, sir.
So what is a better way to store our fuel? Should we look at heated tanks? Should we look at cooled tanks, pressurized tanks?
I have seen a lot of the consulting engineers promoting that through clients. And I have one client who actually put 3 110,000 liter tanks in dedicated buildings, and his fuel from a water content is extremely good. From a contaminant standpoint, not bad.
And that's a cooled tank, or that's a heated tank?
It's a heated environment. So it's a constant environment. It's 65 degrees, I think he keeps it at.
What was the range where it grows the microbes?
You'll start getting that happening when you get temperatures up above 20 degrees.
So if you're at 0, are we still going to get microbes growing at 0?
Well, you get it in summertime for sure. Right? It'll be slow in the wintertime. But you have other issues that you get in the wintertime that you don't have in the summertime, and that's obviously cloud point, and you can actually get water crystals if you have a lot of water in the fuel. And the water crystals can actually plug up systems and filters.
And at what point does heat kill the bugs, the microbes? What temperature do you need?
Once you get them growing, they're not going to stop. They'll go dormant for a while, but as soon as you get the fuel back up, they'll start going again. And it'll be like a sheeting action on the outside of the tank, or that emulsified layer that we had in that picture.
Do you have any application in the aviation industry? I mean, water and aviation fuel is serious.
We haven't gone for certification on that. It's a long process. We were concentrating on getting this particular industry up and secure.
Because they're getting plugging. They have
that's
cases of
exactly
plugging,
the same issues.
changing temperature at altitude.
Well, I found out too with a helicopter, if you land that helicopter, you have to take the fuel out of it and refuel it.
This tank which you mentioned, indoor or heated environment, which material of the tank was carbon steel or fiberglass?
No, steel. Double-walled steel tank. So the other thing on the helicopter thing, it would be interesting there because our filter is considered to be an absolute filter. So one pass through the filter, it's as clean as it's going to be. So they could pull the fuel off and refill it and have certified fuel again. But a lot of that industry is coalescing. Thank you.